Okay, all right, so this is a different class. This is section 1, right? Section 2, we did the first half. So let's pick up where we left off. I'll give you a quick review of what we did, very quick. We looked at some of the early pioneers of the periodic table and how it was put together, from going from the old triads where they compared approximately 40. Could you go around that way, please, unless you want to be on film?
I don't.
All right, excellent. I didn't think so. They had 30 or so, 40 maybe elements, and they grouped them into triads based on physical properties, chemical properties, and see if they could learn more about them by doing that, see if they could understand them, see if they could be placed in some kind of organizational database where they could be more useful. And then they came up with other forms until Mendeleev in 1869-ish. Mendeleev was from Russia, and he came up with the first periodic table, organized according to increasing atomic mass, atomic weight, right? And then we had the modern periodic table, was based on the number of protons or the mass, the atomic number. And there are some exceptions to the increasing atomic weight that didn't work really well, because there were some exceptions, so they used atomic number, which is an excellent way of doing it, because elements are defined by the number of protons. That's the uniqueness. Clear? Now, we looked at noble gases. I want to start with alkali metals. Just call me crazy, okay? And we talked about this already. It's called an alkali metal because when it mixes with water, it produces an alkali liquid, or a liquid that is basic. And something is basic because of the presence of, did we do it in this class?
Water.
No. No. Something is basic because of the presence of water in water. No. In water, water is made basic by the presence of what? Excess what? What ion? No. What is it? No. H2O is water. What is it? OH. OH negative. What's that called? What's that ion called? What's it called? Hydroxide. Think of the cookie. Okay, there's a type of cookie called the hydrox cookie. Okay, it's the OH negative charge, hydroxide ion. That makes something basic. On a pH scale, 14 is very basic, 1 is very acidic. Something is acidic because of the presence of what ion? You can do it, big guy. You can do it. You can do it. You know, you can do it. Get out of retail now while the getting's good. You can do it. Hydrogen ion. Excellent. Excellent. The hydrogen plus ion, plus one ion, okay? So when I put, for instance, when I put sodium into water, I produce sodium hydroxide in hydrogen gas. The hydrogen gas is given off. Sodium hydroxide. You've heard of sodium hydroxide before. Maybe, maybe not. You've heard of lye, L-Y-E. Caustic chemical used in drain cleaners, toilet bowl cleaners, oven cleaners. Your hand, it can burn. It's terrible stuff. Terrible stuff. Does the same thing as an acid does, but just horrible. Feels very soapy. Has a soapy feeling. Very soapy. Feels, oh, that's not harmful. That's soapy. Wrong. Okay. Doing cement work. Doing cement work can give you alkali burns. Okay. Basic burns. All right. So it's called an alkali metal when you put it into water and it forms an alkali solution. In other words, OH is being chopped up into hydrogen, H plus, and OH negative. The H pluses are being combined and being given off as hydrogen gas, and the OH is staying. Anything else on it? Who's doing alkali metals? Who did that? Who's the alkali metal people? How we doing? How was that? Was that good? Anything else you want to add? No, I didn't say alkali earth metals. I said alkali metals. Yes, Bisma. We're going to the alkali group. Okay.
No, you pretty much covered it.
I pretty much covered it. Excellent. That's high praise coming from Bisma. Excellent. Anything else? Anything I'm missing? Pretty good?
They also have low density
They have low density. I like that.
and
They have low density. The alkali metals have low density.
lithium, sodium, and potassium.
Lithium, sodium, and potassium.
Will float on water.
Will what?
They can float on water.
They can float on water. Very low density. Yeah. They can float on water. Matter of fact, it's interesting. Even the alkali earth metals, like calcium, when I think of something that has low density, I think of calcium. If you ever saw it, I have some in the back. I don't want to take it out right now, but it's very brittle. It's kind of like, I don't know how to describe it. It's a gray, dull, just very low density substance. It looks like, doesn't look like anything like a metal, really. It looks like a crumbly, like a cookie almost. It has that, kind of looks like it was baked. Kind of has a baked feeling to it, you know. Alkali earth metals. What can you tell me about, Professor Malik, what can you tell me about alkali earth metals? Anything good?
Yeah, they're almost as reactive as alkali metals.
Okay, they're very reactive as well as these. They also produce an alkali solution. Why earth? Why alkali earth metals? You haven't gotten that far in your thinking? Maybe you want to access the internet and find out why earth. You can put in like, where's the earth in alkali earth metals come from? Okay, maybe you want to look that up. But very similar in terms of everything. Okay, very similar, not as reactive. I mean, if I think of magnesium versus sodium, magnesium is very reactive. But it's not very heavy though, magnesium. Where do they use magnesium a lot? I had magnesium. I bought a lot of magnesium one time. A lot of magnesium. What did I buy? I mean, I must have bought pounds of magnesium, pure magnesium. What did I buy? Well, it wasn't pure magnesium. Well, it was pretty close. A bicycle. A lot of magnesium frames, magnesium alloy frames. Okay? Yeah, a lot of magnesium there. A lot of magnesium in bikes. Yes, Andrew.
They're called earth's metals.
He has a great voice, very low. He's a radio announcer. This is Andrew's talking. Hi, my name is Andrew. How are you? Okay, Andrew, what do you got?
They melt at such high temperatures that they remain solid in fire.
They melt at such high temperatures. They what?
They remain solid in fire.
They remain solid in fire. Bah. Okay, and that's why they're called earth? That's where the earth comes from?
Yeah.
Excellent. Because they don't melt in fire. Can't melt. I like that. How'd that come about? Anything else with that? That was kind of interesting. I need a few intermediate sentences though in there, I think. They're so strong, so they don't melt in fire. I like that. As opposed to what? What melts in fire? I mean, what can melt? I mean, you can take a flame and melt gold, right? For instance, right? Iron, right? Right? Making iron, yeah. Okay. All right, so what else do we have? Anybody, did you look up chalcogen? What do you got, Haley? What are the chalcogens?
It's the elements in the group 16.
This one, yeah, the chalcogens. That's very good. What did it say? So that's an old definition. I don't believe that's in your book. Anybody actually read the chapter? I'm being partially facetious, but partially not facetious, partially rhetorical. Anybody actually read it? Okay. Did they mention chalcogens in the chapter?
No.
No, they didn't. Haley, continue.
It's also called the oxygen family.
The oxygen family, I like that. The vertical columns are called families. Oxygen families, the halogens, the noble gases, These vertical columns are called the what? Transition metals, yeah. What else?
Oxygen and its oxides are actually like distinguished from the other ones, even though it's called the oxygen family.
Oxygen is distinguished from sulfur, selenium, tellurium, and polonium, you mean? Yeah, okay, I like that. It's gas, yeah, we can't breathe sulfur, that would be tough. What else?
They're electronegative.
They're electronegative, high electronegativity. And we'll learn about electronegativity, but they're high electronegativity. What else?
They're strongly associated with metal-bearing minerals.
Metal-bearing minerals. Metals. Metals bond with nonmetals, often. Often. Metals bond with nonmetals. Nonmetals will bond together oftentimes. But oftentimes nonmetals will bond with each other like calcium and oxygen to form an ion that then will bond with a metal. Like carbonate will form, and that has charge. You've heard of sodium carbonate? You take for acid indigestion, sodium bicarbonate, baking soda, yeah? You take two nonmetals, you bond them together, you form an ion, put it over there, bring in a metal ion over here, and then bond those together, and you get sodium carbonate. Chlorine and oxygen form a whole 4 really important ions. Perchlorate, ClO4, -1 charge. ClO3 is chlorate. ClO2 is chlorite, -1 charge. They're all -1 charge. ClO, -1 charge is called hypochlorite. Anybody know what hypochlorite is? Anybody ever hear of that? I'll make a bet with you. Every person in here is incredibly familiar with hypochlorite. I'll make a bet. What are you going to put up? I will put up, give everybody an A on the next test. And what are you going to put up? What are you going to put up? You're actually going to do your homework? Everybody's actually going to do their homework this time?
Yeah, okay.
Okay, I will prove it. You ready? Hypochlorite is the active ingredient in bleach. I win. Okay. Oh, what's bleach? Yeah, right. You can't even say that with a straight face. Yeah, sodium hypochlorite is bleach. You ever hear of swimming pools?
Yeah.
Like chlorine swimming? That's what they put in. They put in hypochlorite ion.
Swimming pools?
Yeah, it helps to kill bacteria. Those nasty little buggers, yeah? What else? So what were we talking about? Oh, yeah, we're talking about chalcogens, yeah? The oxygen is really kind of cool. Oxygen bonds with a lot of other nonmetals and at the same time metals. It's really cool. Like you've heard of, everybody ever hear of bone? Bone? Bone, wait a second.
Oh my god.
You ever hear of bone? Wait a second. You ever hear of bone? That's my metal plate. I have a metal plate like right here. Little metal plate. You hear it? You hear it? You hear it?
Yeah.
Yeah.
He's like a super
Yeah, they call me the android. You've heard of AI, artificial intelligence? Well, that's me. Okay, so bone is calcium phosphate. Phosphate is phosphorus and oxygen, makes an ion. Carbonate, you've heard of carbonate? Yeah, carbon dioxide, yeah, calcium, carbon and oxygen. Sulfate, sulfate, nobody ever hear of sulfate? Magnesium sulfate. You've heard of magnesium sulfate, Epsom salts? Anybody, any athletes in here? Yeah, plaster of Paris too. What's plaster of Paris? What's plaster of Paris? Look up plaster of Paris. Aaron. No, Holland. Look up plaster of Paris. Go on. I want to know what I want to know what plaster of Paris is made of. Okay. What else? So we did chlorite, hypochlorite, calcium, chlorine, and oxygen. What else? So oxygen is big, isn't it? Bromate, chlorate, fluorate. Oh, nitrate. Yes? You've heard of salami, bologna, bacon. Okay? I know, you can't say, can I say that in the UAE? Bacon?
Yeah.
Is that all right?
Say it.
I can say bacon? Okay. Well, anyway, why is it red? Why is it red? Why is it red? I mean, do you ever see dried blood? What color is dried blood?
Like a
Dark brown, right? Yeah. Dried blood is iron. There's iron in it, but it's when it's in the +2 state. It's an ion, +2, right? Blood, red blood, rich red blood, +3 state, +3 state. So what you do is you kill the animal, and you make the you package it, and in order to make it red and appetizing instead of dark brown, yuck, I don't want to buy that. You put in nitrate, sodium nitrate, nitrates, and nitrates help to maintain a nice color. Okay? And it actually can cause cancer when cooked at high temperatures, but we won't even go there. Okay? But it does. It can. You take bacon, if you cook it on top of the stove, it makes carcinogens, nitrosamines, really toxic. You cook bacon, do it in the microwave. It's healthier. Yeah, it's kind of gross too, but whatever. Anyway, yeah, bacon cooked at high temperature can cause cancer, cancerous carcinogens called nitrosamines. Okay, so the chalcogens are really important, and oxygen is a chalcogen, very, very important. Okay. When you think of chalcogen, think of chalk. Chalcogen, chalk. Okay, when you think of chalk, what do you think of?
White.
White. What's chalk made of? White. Yeah, thank you very much. Okay, Mr. Retail, yes, it's white. What do you think of it? Okay, so why don't you look up chalk? Give me the chemical formula for chalk. Holland, do we have a word on there, plaster of Paris? What is it?
It's very hot gypsum.
Gypsum, and what's the formula for gypsum? Calcium.
Yeah.
What do you got? Look it up, go on. Chemical formula for plaster of Paris or gypsum. Okay, we'll come back to you. Okay, so the chalcogens, very important. Chalcogens are right here. What about the halogens? What do we got? Yes, we have, yes.
Chemical formula for chalk.
For what?
Chalk.
Chalk, go ahead, what is it? What essentially is chalk?
Calcium.
Calcium carbonate.
Calcium carbonate. Calcium carbonate. Calcium carbonate. CaCO as in oxygen. Calcium carbonate. Chalk. Chalcogen. Yeah. Cool. Are we there? Excellent. Do we have a word on plaster of Paris there, Miss Holland?
It's calcium.
Calcium.
H2O.
No.
Right? Oh.
Yeah, there's H2O in it actually. It's a hydrate. But what else is in there?